All right. Thank you all. Welcome, and thank you for coming to my talk today. Today, we're going to be looking at threat modeling in the context of the Secure Development Lifecycle, or the SDL. We're going to go over the basics of creating a threat model. We're going to talk about STRIDE, which is an acronym that can help you identify potential vulnerabilities on your threat model. We'll also take a little bit of time so you can start creating your own threat model. So have a piece of paper and pencil ready to go. We'll also take a look at threat trees, see how they can help you find security issues, and then we'll talk about triaging the results of the threat model. So first, a little bit about myself. My name is Sean. I live in Seattle. I started my career in web application security at Indiana University, go Hoosiers. I was hired by Microsoft to do security assurance, and I've worked on projects like Exchange, Bing, Xbox One, and I spent 4 years in the Microsoft Threat Intelligence Center. In November of 2019, Android hired me to run the SDL program for the Android OS, and so I've started doing that. So what is that? What is the Secure Development Lifecycle? Well, the SDL is a framework to ensure that applications and systems are developed with a security-first approach. This is a classic representation of the security development lifecycle, and in it we have the different phases: requirements, design, implementation, verification, and release. While this looks like waterfall, it can be easily adapted to any development methodology, and today we're just going to be concerning ourselves with the design phase, and specifically threat modeling. I also give another talk on the SDL, and I would encourage you to take that class either on droidCon online, or catch me the next time I'm giving this talk at a conference, or we have just actually updated the Play Academy, and there is an SDL class on there you can take as well, and I highly recommend it. So what is a threat model? Well, it's a high-level diagram of your service or application that defines where the data begins and ends, where the data flows in and out of the system. It also talks about who or what interacts with the data and gives us a common vocabulary to discuss the threats that are contained within these diagrams. Now, there are a lot of tools to do this. For this presentation, I used the Microsoft Threat Modeling tool, which is a great free tool if you run a Windows shop. However, there are a bunch of other ways to do this too. You can use Lucidcharts, Visio, a whiteboard, a pen and paper like we'll do here in a little bit. Threat Dragon from OWASP is also a really cool tool, especially if you use Git. The tooling really isn't important. What's important are the threats that come out of the diagram and the discussions that come from the diagram that are the most important thing. So let's go ahead and let's just dive right in. So the elements of threat modeling are composed of the 5 items you see before you. No, we'll talk a little bit later about how you can make this process a little more complicated, but we're going to start simple with these initial 5 elements. First, a data flow can either be a network data flow or inter-process communication. In the example we're about to see, we're going to do a network diagram, but this can also be on-device traffic as well. An external interactor is a really important part of the threat modeling because input doesn't just appear in your system. Data comes from someplace. Oftentimes, that's a place you don't control, such as a human or a third-party service. A process can be an either actual service running on a device, or it can be a logical conceptual grouping of processes that do the same thing. For example, a web service can be drawn as a single process, even though it consists of multiple worker roles that are doing the same functional thing or all working to achieve the same functional goal. A data store is oftentimes a database. They can also be a file on a disk or a memory location. And then finally, we have trust boundaries. Trust boundaries are any time data flows to or from a system that we don't control. And we'll talk a little bit about that in a second. But let's get started. In this presentation, we're going to be talking about Super Cool Game Company and their threat model, but the lessons really apply to any application. We'll start with the game client. It's probably way more complicated than this, but we can represent it with a single circle. In our example, the game makes requests to a front-end web service, and the web service responds and gives us data back. Notice there are 2 data flows, one into the front end and one out of the front end. We always want to model data in both directions. We always want to make sure our data is going in both directions. And there are some instances where it would be one direction, like a data sync, but in most cases, you want 2 data flows. The game client calls the front-end server over the internet, so we'll also add a trust boundary too, because the data is traveling over a untrusted network location. The front end calls the back end data store. Since this is all over our back end, we don't need to use a trust boundary, but we could if we wanted to. This database then fetches game data, returns it to the front end. And so this is really our first threat model, and I'm calling it as incomplete. Why? Well, we've diagrammed the game. It's very simple. We call the front end web service, the front end calls the back end. So from an infrastructure standpoint, we are complete. So it's not a trick question, at least not from that perspective, but what does every application have, or at least we hope they have? Users. We always want to represent the human or external interactors with our threat models. So what we see now actually represents the complete data flow. This is also important because we never trust the user. Now, if you learn nothing more from this course, nothing else from me, please let it be never trust the user, ever. Not customers, not employees, not admins, no one. Never trust the user, and you will build more secure applications. And we'll see how this plays out later in our example when we come back to this threat model. But let's talk about those trust boundaries for a second. This seems to be a place where people get caught up debating whether or not there should or shouldn't be a trust boundary on this specific data flow or not. We use trust boundaries anytime data flows to or from a system we don't control. And if you're ever in doubt, go ahead and use a trust boundary. The result of using a trust boundary will trigger all the elements of stride, which we'll see here in a little bit. But even if it does, maybe that's not a bad thing. Maybe looking at all the threats just means you're more likely to kick up possible threats as you go through this process. And it's just a couple extra acronyms. So if you're ever in doubt, just go ahead and put the trust boundary on there. So you always want to keep your threat models up to date. Here we've added multiplayer functionality and Google authentication to our very simple threat model. When you keep your threat modeling up to date, then you only have to threat model the difference when you add new functionality, because the existing functionality has already been reviewed and hasn't been changed. So far, what we've looked at is the L0 or level 0 threat model. And generally, this is the 30,000-foot view and where you want to start. But we can also drill in. Remember that a process can represent a logical grouping of actual processes. That's the case for our threat model. So in fact, the multiplayer process and the front-end web service are actually far more complicated. So we can actually create a L1 threat model that blows this up into greater detail without threat modeling the rest of the service. This would be the L1 threat model for our online services. Note, we're just zoomed in on that part of the threat model, and we've left everything else. Now we can go back to this diagram and see if we can find additional threats with this increased detail. So up to this point, you may be thinking, well, threat models just seem like a DFD with extra steps, and to agree, that's actually true. But where the magic happens with threat modeling is when you add the STRIDE acronym over the top of it and start looking at the individual threats posed on your DFD. So you've heard me talk a little bit about STRIDE. STRIDE is an acronym that stands for spoofing, tampering, repudiation, denial of service, and elevation of privileges. Almost all threats you face boil down into one of these buckets. As you can see, the elements of STRIDE now map back to the elements of the diagram elements, which you see the elements on your threat model, and then you can see which elements are vulnerable to which sorts of attack. And we'll see how this works later with threat trees. But for right now, let's talk about each element of STRIDE. First of all is spoofing. This is when an attacker can impersonate an account or service. An example might be when an attacker can impersonate a player account. The way we mitigate this is with strong bidirectional authentication. Remember, we talked about how we want to make sure we look at both directions of the data flow. This is how we also get into bidirectional authentication on those data flows. And the bidirectionality is really important because to be secure, data flows need to be mutually authenticated. Tampering is when an attacker can change data either in transit or at rest. The canonical example of this is a monkey in the middle attack, wherein traffic is routed through an attacker's network and is able to change the packets on the fly. Cryptography is our solution here. Strong cryptographic message signing and a secure channel through which to send the message. Repudiation can be thought of as the 5 whys of journalism. Who took the action? What was the action? Where did the action take place? How did the action take place? Was it an interactive command? Was it a cron job? Was it a user? And when did the action occur? This is often accomplished by sending logs and telemetry to a centralized and well-protected service. This is the part of the talk where I like to bring up the fact that I am definitely not a lawyer, and there are intricacies involved with logging, and I urge everyone to speak to your legal counsel for logging guidelines applicable to your industry and location. We talked about cryptography and transit for data flows and the need for secure channel and the spoofing threat. We also need to talk about data at rest. And one of the mitigations here is cryptography, which really mitigates scenarios such as an attacker coming into the data center and stealing your hard drive, which is something you definitely want to talk about. But it also prevents the data from being stolen off the phone properly, if done properly, or a device, not necessarily a phone. I say phone because, you know, I think that way, but device or whatever you have. You also need to think about how the data is stored at rest, and the accounts accessing the data have the lowest privileges possible to execute a task. So your principle of least privilege comes in handy here too. Row level authorization and things like that are really key. While not necessarily part of the design phase, penetration testing can help you out with this too. You can bring in outside consulting firm and they can help you get PII out of the systems. That's a process I strongly recommend, even though it does fall later in the verification phase of the SDL. A DOS is when an attacker can cause either local or server-side outages in some way. An example of this might be a malform request to our front-end game servers that takes them offline. This is a really hard one to try to find and mitigate, but generally speaking, the guidelines here are a good design which is globally scalable. Fuzzing is also a really cool technique that's very important in this area. If you're not familiar, in a nutshell, fuzzing is where you throw malformed data into your application and see if you can make it crash. Sometimes these crashes are exploitable, and even if they're not, what you found are reliability bugs. So fuzzing is a really good twofer activity you can do to find security and reliability of bugs. Also, network appliances, when we're talking about network services and we talk about game services, network appliances, cloud appliances can help with distributed denial of service attacks as well. Finally, elevation of privileges. This is when an attacker can go from an unauthenticated user to a regular user, or from a regular user account to a super user account, or actually, I guess you could go from an unauthenticated user to a super user account, which would be like really, really terrible. But in our example, this would be if an unauthenticated user could get access to the game data, which they shouldn't be able to. The way you prevent this is with strong authorization system and a good design. And again, testing. I can't stress to you enough how good pen testing is as an activity to engage in to find things like this. So far, we've gone ahead and we looked at all the elements of STRIDE. We've gone through what all the elements of threat modeling. And so now what we want to do is take maybe 3 minutes and create your own L0 threat model. I said earlier, and I also posted in the chat, make sure you have pen and paper, if you have whiteboarding, an iPad, whatever you want to use. But why don't we go ahead and try to look at your own threat models and create those. And if you have questions, pop them in the Slido. I'm going to ask our folks listening here from the droidCon if they can switch over to Slido if we have any questions, and see about that. And I'll try to answer those as we go through this. But go ahead and think about where your data is, where your threat model begins with your Android application. Where do you call out? What sort of services do those services call? And see how much of a beginning of a threat model you can do just while we're sitting here. I'll give everybody a few more minutes. Make sure you think about how your users authenticate. What is your authentication mechanism? Some of these components of your threat model are sort of taken for granted. And when you start walking through step by step your call stack, who you call, what you call next, you will end up kind of seeing those. All right, we've got the Slido. Let's see here. And it doesn't look like, I think it does that when we don't have questions. So that's pretty good. Either I'm answering everybody's questions or I've gone so fast through it, nobody has any idea what I'm talking about. So I know which one I hope it is. I'm going to go ahead and, by threat model between client and server, you mean maybe a TLS layer on top of that data? Yes, absolutely. So when you have a threat model between client and server, yes. A TLS would be a mitigation, would give you a strong cryptographic channel through which to send your messages, and would also give you message integrity. So a countermeasure, or like whenever you have data flowing over a trust boundary, a TLS is generally your mitigation in that area. Absolutely. All right, I'm gonna share back out my screen to our folks and we'll just keep moving on here. Let's see. All right, and everybody should be able to see this here. So hopefully you have in front of you a threat model. And so now we're going to move on and we're going to talk about threat trees. And we're going to look at trees to see if we can find any vulnerabilities on your threat model. And I'm not going to go through all the permutations of threat trees because we don't have time and there's a ton of them. But we're going to look at 3 of the heavy hitters from threat modeling. And I would recommend downloading the SDL book at the bit.ly address there. I've shared, I'll also put it in the speaker's notes afterwards. It's a really great free resource. It's a book by Steve Lipner and Michael Howard of Microsoft fame. And they have a ton of threat trees that can walk you through this too, as well as general SDL guidelines and a little bit on threat modeling. It's an older book, but it's actually a really good read and you can't beat the price. So first, we've got elevation of privilege. How would someone try to get higher privileges on these processes in our threat model? Well, first thing you would do is you would look at dynamic corruption. And this is when the fuzzer is, or this is when the running application is attacked via input or access to memory. So shared memory usage, use after free, things like that, dynamically corrupting the running app. Much of this can actually be found via fuzzing that we talked about earlier. So I strongly recommend that approach. Static corruption, can the code be, or the binary be altered? Can it be altered on the server side or the device? Android definitely affords some mitigations for applications on the device, especially if they come from the Play Store. But application signing and the Play Store don't mitigate side-loaded attacks, so this is something you definitely want to consider as you go through your threat trees. Also, insufficient authorization, cross-domain issues can exist, such as cross-site request forgery, cross-site scripting, which still actually exist, trusting code from another site, violations of same origin policy, things like that. You can also have call chain issues. Do you trust all the code that calls your code? Do you own an SDK or any web APIs that other people may be calling? Do you trust code that you call? So do you have any remote JavaScript libraries? PHP includes things like that on your server side that you're calling remotely, and how much do you trust that code? The next thing we'll take a look at is data flow tampering. So how would you tamper with the data flows involved here? Well, you would either violate the message integrity, and you do that either through spoofing, which we'll take a look at in a second, spoofing the message integrity, replay attack would be being able to take the message because there's no message integrity, taking a message that is maybe a winning shot in a game and being able to replay that data traffic over and over and over so that the score keeps running up. Collisions, so having data that because the message integrity is weak, 2 messages that might equal the same thing. No message integrity, or weak message integrity being basically there is no message integrity, so you could alter or tamper with the bits at your leisure if you were in a man-in-the-middle attack or something like that. The other thing is the channel integrity. So we have man-in-the-middle attacks, again, because your channel integrity would be weak. No channel integrity or weak channel integrity, all sort of together there as that nexus of bad data flow stuff. Then there's also spoofing a process. So how would you go about spoofing these processes? Well, the first thing you would do is you could try obtaining the credentials. Generally, you obtain credentials in one of three ways. You have the weak storage, you have weak transport, or you have weak change management. Weak storage being you're keeping them somewhere, either on a piece of paper, you're keeping them on a file area that you shouldn't, you're keeping them outside of protected storage. You're transporting them, like we saw in the last threat model, over a weak channel integrity, so we can grab the credentials from there, or a weak change management process. So when we talk about change management, how often have you rotated the root credentials or the root certificates or any of those things in your company? What is your policy on rotating your keys? That's a really, really tough one, something that we struggle with, especially in our area, and something that it's hard to work on, but it is something that we need to do. Also, remember that your weak storage can be on the server, the client, or your KMS can also be a problem, or checking in keys to source code, source depot, Git servers, things like that. You can also falsify your credentials. You can either guess them or you can have an equivalence. So if you're rolling your own password management and you're doing something simple like MD5ing a password, you might be able to find two passwords that are the equivalent of each other. Also, you can guess, sometimes password, so, admin password, root password, that sort of thing. Hopefully nobody is doing that. Insufficient authentication is where we get a lot more of these. So null credentials, downgrade authentication, and predictable credentials. Predictable credentials are my absolute favorite. So if you have web server 001, and then you always use password 001 or password web server 001, so that if you get one of the passwords, you immediately have the password to every other system. I've seen system administrators just have very, very bad days because of decisions like that. And then finally, no authentication. So hopefully that's not the case either, but obviously you can spoof with no authentication pretty easily. So severity and triage, not all elements are equal. Critical vulnerabilities for us in Android world are information disclosure and elevation of privileges. So somebody being able to get data off of your device is super important to us, or being able to go from an unauthenticated user to an authenticated user or to a root user is of our highest concern. Under that, we have high vulnerabilities, so remote permanent denial of service, so being able to brick a phone, spoofing, some tampering falls into that bucket. And then in the moderate vulnerability bucket, we have tampering, repudiation, and temporary denial of service. But your severity may be very different than ours. We are running an operating system for nearly 3 billion devices, so the way we view the world may be very different than yours. You may not really have any information disclosure or elevation of privileges, but cheating and tampering and spoofing may be the most important to you. So really, it's a matter of looking at the risks on the STRIDE model and trying to figure out, to my industry and my core business, what are the most important. Also, a note about objects. Basic is good, but we can be more advanced. So instead of a generic data store, why not say it's a MySQL database and look at the threats attendant to that technology? Instead of a generic game client, you can say an Android game client, and then add on to STRIDE other issues that come along with that, such as cheating, such as side loading, whatever you might end up having that is industry specific in that area. Same with the front end. You could say, instead of it's a front end service, you could say it's your Google Cloud Web Service, and you could start bringing in, well, we know it's actually a web service, so are we worried about cross-site request forgery? Worried about cross-site scripting, that sort of thing. As you get more experience with threat modeling, you can start to bring your own concerns, and you can start to diagram those elements. And so with that, I'm going to go back to the Q&A form. I want to definitely call out the Play Academy training courses. This course is going to be on there soon. The SDL, or Secure Development Lifecycle training courses there. I'll put the link to the bit.ly address in the notes later, but that is to the SDL book. Safecode.org is a wonderful nonprofit that does a lot of threat modeling, a lot of SDL work. It's done by a guy named Steve Klipner. Really love those guys. And then Threat Dragon, I talked about a little bit. Threat Dragon is a wonderful application for doing threat modeling, especially if you use GitHub at all. You will love it. And then the Microsoft threat modeling tool is another tool that you can use. And like I was talking about earlier, you can do those customized stencils, customized objects. You can do that through a lot of those tools as well. All right. So let's do some questions here. For API keys in project codebase, what strategy should be used as it is exempted from obfuscation? APIs in a project codebase, what strategy should be used? Well, it depends. That's a really hard one to, I hate to punt on something like this. It's a hard one to answer in the abstract because I don't know what your setup is like, but obviously you want to keep your keys in some sort of HSM or some sort of high security module. And then it's really about putting something in your code and having your build process be able to go out and either get the keys and bring them in or put them in some place that is secure so that they're just in time. So you're just getting them when they come out or when you need to use them for calling APIs and whatnot. So it depends. It really depends. I don't have a good answer for you there without knowing more. If you want to follow up after this with me, maybe if I know a little bit more about your environment, I can give you a little bit better guidance, especially about what your build process is and how you're, what exactly technologies you're using. How to safeguard something like Firebase server key tokens in Android? Suggest some best practices. The best place to put things would be the key store, especially if the Android key, especially if you are targeting devices that have security modules or have like the Titan chip, like the Pixel has. That is definitely the key store is definitely the place to put any sort of tokens. Yes, that would be my best practice. Would you recommend SSL pinning in a regular app? Does Google Apps use it? I like SSL pinning. I don't know if Google Apps use it. So the one-party apps aren't actually developed by Android themselves. They're developed by the teams, and I'm not sure if they do it, but I do like SSL pinning. I do recommend using it. Yes, big fan. There's not really a downside to it. Are there any other questions? All right. Well, if there are no other questions, feel free to follow up with me on the speaker page. And yeah, I guess we'll give everybody back a little extra time.